Alright, hey everyone. So, I had a student asking me a question for the newest VEX game, Tipping Point. They're trying to create a funnel so that way the little donuts or whatever slide in this way and then straight on up, even if they come in at the fringes of the robot. And they weren't quite sure how to position metal from the configured parts library, a piece of metal that already exists. They weren't sure how to position it at an angle like this. They had effectively just dragged it into position, but that's not very stable because, well, it's not affixed to anything. You're free to drag it around just like you dragged it there. So what I've done here is I've created just a very simple, maybe left half of your base. You might have a drive wheel up over here and cortex over here, and it flips to the other side and you get a base. So I'm going to show one possible way of mounting this plate at a weird angle. Now, in VEX, if I were to just go to do a fasten mate as I would normally, maybe I pick this hole, center of it, because we don't want to pick the edge, and then the center of this hole, right? We already have some options built into that. Right now, the options you guys are probably most familiar with are going to be flipping the orientation of the mate. So if the plate of metal was inside the C channel like this, then you'd press that and flip it out. Or reorienting the secondary axes. You can spin it around in 90-degree increments. There are more options than that. Some of you have probably started exploring this offset checkbox. You check it and you get 3 more options for X, Y, and Z. If you see this little coordinate icon that appears down here, it shows what X direction is, what the Z direction is, and what the Y local direction is. So let's say I want to move the part out like an inch away for some reason when I'm mounting. Well, it just went backwards. How do we fix that? We'll just put a -1 inch in the Z coordinate. And now we can see that the part has moved, but they're still parallel. This isn't a funnel. This is, well, first off, illegal because I'm not cutting metal like that to have them intersect each other. So let's make this something actually useful. We'll put this at like -0.5 for now. How can we spin this? Well, we can't really do it in the same mate. Or you probably could, but let's just continue using fasten mates because that's what y'all are familiar with. What we're going to do now is make a mate connector. Control M, it's in this top left. Look at my mouse. We press it and it works like a fasten mate. You pick the spot you want it to exist at, so let's maybe pick that spot, right? Let's give it a click. There we go. And it creates a mate connector, but for all intents and purposes right now, the mate connector already exists in that area. What's so special about creating a mate connector is you can realign and move it. Let's just move it for now. So how about we offset the mate connector -0.5 out. And you're going to sometimes have to check that negative. Just if it goes the wrong direction, just put a negative or remove a negative. So the mate connector is now offset away from the face. That's good. We're getting one step closer to having it rotated. Now this is where you wouldn't be able to do something as easily with a fasten mate. You can go down here and rotate about axes. Let's say rotate about X because I want to spin it around this red one. And we're going to spin it 15 degrees. And we just saw it tilt. Look, they're not parallel anymore. So that's how you get the first direction of tilt. Then what you can do is you have this thing called a mate connector just existing in space. You can mate to that. That's why it's a mate connector. You connect to it with a mate. So we're going to click this corner of the plate just as we were before. But instead of clicking the hole in the metal this time over here, we're going to click the mate connector. And we see we have that tilt. It maintains the tilt onto the piece of plate. Or the plate is also turned. How do we spin it in a second direction though? Well, now you can go in your fastened, offset, and you can keep these values at 0 or you can plug stuff in if you wanted to shift it around. But what we're going to do is we're going to rotate about Z. Now, I'm getting Z from looking at this little local coordinate axes of the part. I see the blue one, that's always going to be Z, and I want to tilt it up this way. So let's tilt it 15 degrees. Wrong way. Add a negative and we're good to go. Accept, close out, and now you can see that this part, this plate, is fastened to the base, and isn't going anywhere. How would you attach something like this in real life? Probably zip ties, or you would wind up bending some pieces of metal. But While this is one way to do it, there are others that involve rotating the mate connector in different ways first. However, this is a great exercise into how to use a mate connector. But remember, when catting, get the big framework of your robot done first before starting to do small details like this funnel, because this is more likely to change as it directly interacts with the game objects by giving them that compression needed to get them sucked up into the robot. Anyway, hope that helped, and see you later.